In this video, I'll be helping you with the ALEKS problem type called Rationalizing a Denominator Quotient Involving Square Roots. In this example, we're asked to rationalize the denominator here in the fraction 9 over the square root of 6. And to rationalize the denominator, we need to remove that square root. And so looking at that square root of 6, the first thing I would try to do if possible would be to simplify the square root. But the square root of 6 isn't one that I can break up into perfect squares, so there's no simplification here that I can do for the square root of 6. So I will use the fact that I can multiply a fraction by 1 and not change that fraction. And to rationalize the square root of 6, I want that 6 to be a perfect square under the radical in order to remove the radical. So multiplying by another square root of 6 will do that. And of course, since I need to multiply by 1, putting a square root of 6 in the denominator means I must also have one in the numerator. So again, technically I'm only multiplying by 1. However, in the numerator, I now have 9 square roots of 6. And in the denominator, the square root of 6 times the square root of 6 is the square root of 36. And as planned, the square root of 36 can be simplified to just 6. 6 squared is 36, so the square root of 36 is 6. My denominator stays the same. So we have rationalized the denominator. There's no longer a radical. However, I can simplify further because both the number outside the radical in the numerator and the number outside the radical in the denominator, 9 over 6, those are both divisible by 3. There's a common factor of 3 that will cancel. So dividing both of those by 3 would give me a 3 square roots of 6 in the numerator, and in the denominator, 6 divided by 3 is 2. And I just want to point out here that while we may be tempted to try to cancel the 6 and the 2, the 6 is under the radical and the 2 is not. So there's no canceling there to be done. So this is our simplified solution.